All right, good evening and welcome to Master Talker online class. In today's video, we'll be talking about capacitor, right? All right. A capacitor is a device for storing electric charge. Okay, any device used in storing electric charge is called a capacitor. All right. It consists of two metallic plates of equal but opposite charges separated, okay, by a small distance by an insulator, okay, of a small distance. Or let me say that they are being separated a small distance by an insulator. So what do I mean? If you look at this, once you see that this line is equal to this line, anywhere you see that this line is equal to this line, just know that that thing is what? A capacitor. Then if you look at this one, you see that maybe this one will be long and this one will not be short. Then this one is a cell. Okay, so for you to know the difference between a cell and a capacitor, in a capacitor the parallel plates are equal, they are equal but opposite. All right, so I have here Q minus and here Q positive. Then they are being separated by a small distance. Then there is an insulator in that small distance. All right, so you write for me that this one is a potential difference V. Right, so you can write that you should know that the formula for, okay, so the next thing you write for me is what? The capacitance of a capacitor. The capacitance of a capacitor. The capacitance of a capacitor. All right. The capacitance C of a capacitor is the measure of its ability to store electric charge. So the ability, if you want to measure the ability of a capacitor to store an electric charge, okay, then you are calculating the capacitance of that capacitor. Okay, another word you can use for capacitance of a capacitance of a capacitor is defined as what? The charge per unit potential difference, all right, between them. All right, the capacitance is equal to the ratio, so the ratio of the charge on either plate or slash conductor on the potential difference. So if you have charge per unit volt is capacitance of a capacitor. So capacitance of a capacitor C is equal to what? Q over V. But I don't used to remember this formula. I just need to know that what? Q is equal to campus vibes. Please, I used to call it campus vibes. Yes. C is equal to what? Campus vibes. That is my channel. Let me use this medium to advertise it. Okay, you can please subscribe to it. It's called Campus Vibes. Campus Vibes. All right, where students on campus bring out their talents. Okay, they are all in all social media platforms. They are in YouTube, Instagram. We use Z, please. We don't use S. We use Z. All right, Campus Vibes. So that is that. So if you remember that Q is equal to campus vibe, and what is this campus vibe? Campus vibe means capacitance and then potential difference. Okay, don't forget that Q is your what? Your charge. Okay, yes, and campus vibe, they are always charged. Yes, they are always charged. So remember that campus vibes are always charged. Okay, so we are talking about students that are charged with their talent. You talk about campus vibes. So this will help you to remember this formula. Okay, so where C means what? The capacitance of the capacitor. And don't forget what capacitance is. Capacitance means you want to measure the ability of that capacitor to hold an electric current, okay, or electric charge. Then your Q is what? Your Q is charge, and then your V is what? The potential difference. So that is that. So if you remember that C is now Q over V, you can now make C solve a formula to get Q over V, and this is what? Charge is measured in coulomb, while volt is measured in what? V. So coulomb per volt. Your capacitance is measured in what? In coulomb per volt. All right, so let us take a question to illustrate that. And then another formula for, another unit apart from coulomb per volt is farad. So capacitance is measured in what? In farad. Okay, please don't forget that. Capacitance is measured in farad or coulomb per volt, anyone you like. So don't still forget this our formula, that campus vibes are always charged. So you have that what? That is the formula. Campus vibes are always charged. So let's take a question to illustrate that. I have that what? A capacitance of a capacitor is 2 μ farad. Okay, sorry. So let's take an example. This example said a capacitor of capacitance, right, of capacitance 2 μ farad, 2 μ farad is charged from a 12 volt battery. It's charged from a 12 volt battery, all right, and discharged through a milliammeter in 0.02 seconds. All right, then I say determine the current recorded by the milliammeter. All right, so this is very, very simple. Solution. Okay, so we want to determine the current. Don't forget that what? Q is equal to IT. Don't forget this formula. Q is equal to IT is a very important formula you need to know. And then the same Q again, charge, campus vibes are always charged. The same Q again is equal to what? CV. So if you connect the two, anywhere you see this, you can put this. So it means what? IT is equal to CV. All right. So where is my C and where is my V? So bring out all your parameters. You bring out all your parameters. They gave us that C, the capacitor, is what? 2 μ farad. And mu means 2 times 10 raised to power minus 6 farad. All right. And they gave me my V. My V they gave me is 12 volts. All right. And they gave me my T. The time they gave me is 0.02 seconds. Okay. The only problem I have is I need to find my I. So if you put everybody here, you will see that your I will now be what? CV over T, which is what? What is my C? That is 2 times 10 raised to power minus 6 times my V is 12, then divided by 0.02. So if you do that mathematics, you'll be having 1.2 times 10 raised to power times 10 raised to power minus 3 ampere. So that is your current. All right. So don't forget that what? Q is equal to IT, and Q is equal to campus vibes as well. So that is that for that. We'll still solve more question on capacitance of a capacitor, right? All right, so write for me. So subheading, right? The parallel plate capacitor. The parallel plate capacitor. The parallel plate capacitor. Right? The parallel plate capacitor. Write for me. Consider two parallel plates of a capacitor, each having a charge numerically equal to Q. Okay, they say that the charge is equal to Q. All right. Okay, and comma, the dielectric is a material of permittivity E. The dielectric is a material with permittivity E. Okay, and the area of each plate is A. The area of each plate is A, and the distance of separation is D. The distance separation is D. And then I said the electric field strength is E. The electric field strength is E between the plates All right, E on a charged plane conductor is given by, okay, they say that E is given by uh, delta over what? Over E. Delta over E, where this delta or rho is what? The surface charge density. The surface charge density. Okay, an important formula. The surface charge density, and then, okay, and then we have that but we know that this surface charge density is equal to charge over area. All right, is equal to charge over area. If you now put it in the formula, you will have that this is E. Your E is equal to what? Q over what? AE. All right, Q over AE. So we now have that don't forget that this E is still volt per distance. Okay, the volt over distance, don't forget volt per meter. So the volt over distance is equal to what? Is equal to Q over what? AE. Okay, so if you now do that, if you cross multiply, you'll be having that. I want to bring this down, take this up to have that what? That my V over Q is equal to what? D over AE. Okay, so which is if you turn this around, so you have that Q over V is equal to what? AE over what? D. And Q over V means capacitor, so capacitor is equal to what? AE over what? Over D. So that is the formula. But without knowing this derivation, you should know that, please, without knowing all this stupid derivation, you should know that what? The capacitance of a capacitor is directly proportional to the area, okay, and then inversely proportional to the distance apart. Okay, the area of that plate and then the distance apart. So if you remove proportionality sign, you have that what? C is equal to what? E naught over what? E naught A over what? Over D. So where this your E naught is what? Permittivity of free space. This is permittivity of free space. Okay, so that is that. Very important formula to note. This formula is very, very important to note. So you will see that what affects capacitance of a capacitor is what? The area of that the plate and then the distance apart. That is two major things that affect capacitance of a capacitor. All right, so let's continue. All right, the next one we look at is relative permittivity. The relative permittivity, ER. Relative permittivity. Permittivity. All right, relative permittivity, that is dielectric constant. The dielectric constant. Relative permittivity or dielectric constant. Dielectric constant. All right, that is your ER. Okay, very important. So write that as a subheading. So you have that given that the capacitance of a capacitor, C, the capacitance of a capacitor when there is in fact, you know that your C is equal to what? Directly proportional to A and inversely proportional to D, where your E is what is it called? Is permittivity of free space. So E naught. Then anytime there is dielectric constant or relative permittivity, just multiply it with this man. Okay, so you have that C is equal to what? E naught ER, then A over what? Over D. So this is very, very important. We did it in our video on what is it called? The former video I did on What topic was that, Seth? Remind me the topic. Where is my textbook? That's the first topic we did now. That is electrostatics. We did it in electrostatics. That's where we have Coulomb law, all those. That's the electric field. We did it in electric field. All right. That whenever you have ER, it must be multiplied by your E naught to get the main thing. Is a must, please. Is a must. All right. So that is that. So let's take a question to illustrate that. Let's take a question to illustrate that. In fact, anywhere you have ER, ER must be multiplied by your E naught. Is a must. We don't throw it away. It must be multiplied. We did it in electric field, right? So they said a parallel plate, a parallel plate capacitor, a parallel plate capacitor consists of two plates, each of area 9.6 times 10 raised power minus 3 meters squared. Okay, separated by a dielectric of thickness 2.25 times 10 raised power minus 4 meters. Okay, and dielectric constant 900. Full stop. Now say calculate the capacitance of the capacitor. Okay, calculate the capacitance of a capacitor. All right. So solution. Okay. So what do? We're coming to that. So we have that solution. What do? What did they give us? We have area. They gave us the area as 9.6 times 10 raised power minus 3 meters squared. Okay, and they gave us that the thickness, that is the distance apart, is the thickness. So the distance is 2.25 times 10 raised power minus 4. Okay, but they gave us ER. Our ER is 900. But don't forget that E naught is a constant, please. E naught is always a constant. They may give it to you, but if they decide not to give it to you, you should remember that it is 8.85 times 10 raised to power minus 12, please. Very, very important. Okay, is a constant, minus 12. So what do we have? You will now have that C is directly proportional to A and inversely proportional to D, where you have your E, R, and E naught. So that's how I used to remember this formula. So what do I have? I will now have that my ER is 900 times my E naught is 8.85 times 10 raised to power minus 12. Then times my area. My area is 9.6 times 10 raised to power minus 3. Then divided by my distance, 2.25 times 10 raised to power minus 4. So if you do that, you'll be getting 3.4 times 10 raised to power what? Minus 7 farad. Right? So that is that for that. We keep moving. So let's take one more question on that. Okay? Let's take one more question. They said a parallel plate, a parallel plate capacitor of area 10 cm squared in a vacuum has a capacitor have a capacitance of 10 raised to power minus 2 mu farad. Then I say what is the distance What is the distance between the plates? Between the plates. All right, solution. This is very simple. Let us bring out what we are given. First of all, they gave us area, and the area they gave us is 10 cm squared, which is what? 10 divided by 100. Because it is squared, that my 100 should be squared. So what do I have? If you divide that, you'll be having that your area is that is 10 divided by 10000. So this cancel this. I'm going to have 0.001123. All right, meter square. That is my area. So the next thing they gave me is the capacitance C, and my capacitance is 10 raised to power minus 2 μ farad, which is what? 10 raised to power minus 2 times 10 raised to power minus 6 farad, because μ means times 10 raised to power minus 6. So both of them will give me 10 raised to power minus 8 farad. All right. So what else did they give us? Did not give us anything, but we should know that our E naught is always 8.85 times 10 raised power what? Minus 12. Please, very very important. So we now have that what? C is directly proportional to area, but inversely proportional to what? To the distance separating them, where you have this as your constant. So if you have, I want D to stay alone, D will now be what? E naught A over C. So which will now give what? What is my E naught? My E naught is 8.85 times 10 raised power minus 12 times my area. My area is 0.001. Then divided by my C. My C is 10 raised power minus 8. So if you divide that, you will be having so divide that, you'll be having approximately 8 point, you will have approximately 8.85 times 10 raised to power minus 7, okay, meters. So that is the distance separating them. So this is a very simple question. So we move to the next question. That say that a parallel plate, a parallel plate capacitor, of plate area, 20 cm squared in vacuum, has a capacitance of 0.02 μ farad. Okay, they say if permittivity of free space is 9.0 times 10 raised power minus 12, calculate the distance between the plates.